I'm Anil Kumar, and here is an extended question from the chapter 5.1 Advanced Functions, Reciprocal of Functions. Sketch the graph of reciprocal of y equals to sine x. Well, it is not a rational function, but it is reciprocal of sine x, which we are talking about. So reciprocal of sine x, let me call this function as r of x is equal to 1 over sine x. So from the graph of sine x, we will sketch the graph of reciprocal function 1 over sine x, correct? So to begin with, let me just make a very rough sketch here. So let's start with a sine wave, right? So it continues forever, but we'll consider one wave, and then you can think of repeating the same thing, okay? So let us say this is our sine wave, right? So let me draw the x-axis kind of like this, and the y-axis starting from here. Now, as you know, for a sine function, maximum is 1, minimum is minus 1, right? The period of the sine wave is 360. Let me write them in degrees for the time being, right? So this is 180, and this one will be quarter of that, quarter of 360, that is 270. Correct? And of course this wave extends, right? It kind of goes like this. So it continues, but we'll concentrate on just one wave. You can repeat the rest. Now we are talking about reciprocal of the given sine wave, right? Now reciprocal means 1 over the value. Now wherever we have these x-intercepts, at those points the reciprocal function will have vertical asymptotes. So let me draw vertical asymptotes at these points. So always x-intercepts for the function, which translate to vertical asymptotes for the reciprocal function, is a good starting point. Okay, think this is the right. So we get vertical asymptotes, and vertical asymptotes are at n pi, or n times 180 degrees. So we say these vertical asymptotes are at the value x equals to k times, you can say, where k is any natural integer you can take, right? K times pi when radians, k times 180 degrees. So that is the equation for all these vertical asymptotes. Now another important thing is reciprocal of 1 is 1, and reciprocal of minus 1 will be minus 1, right? So let's consider these points, which are 1 and minus 1. These points are invariant points, right? So they will be common in both. So these are invariant points. Now maximum value is 1, so it is the value of sine function is between plus and minus 1. So it is always kind of a fraction. So if I take a value here, let us say which is half, reciprocal will be 2, right? So it will be kind of here. If I go closer to 0 from the positive side, it becomes infinitely large. So the graph will be kind of like this. Do you see that? Same is the case on the left side. So the graph will be kind of like this, and these are the vertical asymptotes. From 180 degrees to 360 degrees, sine function is negative, so its reciprocal will also be negative. Invariant point will be at 270 degrees, 1 minus 1, reciprocal is minus 1. As we approach towards the vertical asymptotes, the value increases. Negative, but it increases kind of like this. Do you see that? So that is how the graph of the function is going to be like, correct? So it is kind of repeated like this. So that is the graph of reciprocal function, as you can see, right? So let us write down domain and range for this function also, right? So domain for the reciprocal function is going to be x belongs to real numbers, but x is not equals to k times 180. Since we have vertical asymptotes at those points, and the range for the reciprocal function will be that y belongs to real numbers, but y is, I mean, y is always greater than equal to absolute value of 1 you can write, right? So, or you can say y is greater than equal to 1, correct? Greater than equal to 1, or y is less than equal to minus 1, correct? So that becomes the range for this function, correct? So that is how we can draw reciprocal of sine function. As an exercise, what you can do is you can draw reciprocal of cosine function. I hope that helps. Thank you.